I click this button. Hello friends, welcome to Coding Adventures. I wasn't live from the beginning, so I think you skipped a small part of the presentation, but the main topic of today's lesson is to discuss about objects. And as I mentioned before, object theory, it's so complex, there is lots of theory, concepts, and design patterns and other concepts behind objects that is totally beyond the scope of this simple lesson. Instead, in today's lesson, basically we are just introducing objects and see the most basic concepts of the objects that we can see. And we saw it last time with the arrays, when we presented arrays. Let me switch back here to my notebook. When we introduced array, we said that an array is a list of items, and inside this list we can place various entities, such as before arrays, each of these various entities were just stored in individual variables, but array allow us for the very first time to combine multiple of these entities in a list and refer it via a single variable. And then later on, when we needed one of these entities, we access it by a number, right? So that's what we discuss about arrays. Now, with objects, we're gonna basically see a similar behavior of grouping multiple pieces of information in a single entity, but instead of accessing them by index, we'll access them by name, which is a very interesting concept. So perhaps we should go here in the code and define a pretty simple object, and then all this will make sense. So let's define an object named car, and the syntax to define an object is basically to use the curly brackets, right? If you remember, for array, we'd use the square brackets. For an object, use the curly brackets. All right, and now inside this object, we're gonna define a few properties. This will be the properties of the array. So perhaps a car has a make, right? And this is a string, and I'll put here a particular make of a car. Pick your favorite car make. And notice how we are defining these properties inside. We put a property name similar to the variable name, then we put colon, and then the actual value. We don't use any keyword in front of this property. We don't use here let or const, any of those things. We just put the property name, colon, and the property value, the value of the property, right? So now, how can we define multiple properties? We just separate them with comma, like we separated the elements inside an array. So let's define a few extra properties here. Perhaps a model, right? I'm not very good with cars. I'll just pick some random car make and model. Maybe they'll even not match. Maybe they'll be fictitious cars. So choose here your favorite ones. Let's pick a color. We can put here a color, just like that. And properties, until now we just defined these three properties as strings, but actually it can be numbers, can be strings, can take any of the data types that we studied until now. Can be booleans, can be arrays, can be even other objects. That's also very interesting. Let's define a number one, top speed. And perhaps this is in miles per hour, let's say 100. All right, so this is how we defined an object. Pretty simple. If we run the program, nothing will happen, we just define it. Basically at this point we have just one variable in our code, which is car, but this variable is actually an object. Think of it like a collection of all these other sub-variables, which are called properties. So they are properties of the object, right? So in this moment we can basically pass the variable around, pass it in functions and use it there. But how can you use it? And how can we extract these properties from the variable? Well, very simple. Let's print one or two of them here. Let's say we are interested to see the make and model of the car. The way we access those, we'll just access them by name, just like that, like with a dot make. If you remember with arrays, we would have said car of 0 or car of 1 to access a particular element. Here, because these properties are named, we just put car.name. And now this is very similar to other properties that we encounter perhaps on the array when we put array.length. because at the base arrays are objects and they have this behavior. So let's run it. Well, we can see very well we access the string, basically the make that is inside the car. Isn't this wonderful? And of course we can access the others as well. So we can basically put car.model plus has top speed. Oh, speed, car.top speed. All right. And if we run this now, we can see basically the result, which is as expected. All right. So as you can see, objects are pretty simple to use. There's no no complication here. It just allows us to group this variable together, to encapsulate them is the term, to encapsulate a series of properties in a single object. So basically, in order to access this, we have to go through the car object. All right. Let me show you something else. It's a little bit interesting. So we can leave this one in the code. Well, if we have basically an object, we can just convert the entire object to string if we need that reason. For instance, we have this helper function json.stringify. json.stringify that basically takes as an argument an object and will return a string. And now let me print this string. And ta-da! it doesn't look like formatted with an enter. Initially when I typed in the code, it's I put an enter here, but note something. What you see here on the screen is actually what is called a JSON file format, or JavaScript object notation. So the entire object has been transformed to a string, to a text. And this is a very important concept and very necessary in certain applications. For instance, if we want to send objects over the wire, or if we are receiving objects from internet, from an application, or if we want to write them on disk, we cannot write memory on disk, right? We have to transform it in some sort of a binary or textual information, and then we can write it or send it. So this is also called serialization. And in modern edition of JavaScript, we have this helper function. Say you just write it like that: JSON uppercase all uppercase dot stringify, and then you pass your object. Notice basically there in the internals, JSON is also an object, and this is some sort of a method of that one, but behaves like a function. We'll just discuss today these simple properties that behave like variables. All right, so basically this is how you define an object, and if you want to convert it to a string, you'll just use JSON stringify, and now we'll not send it over the wire, we'll just keep it on our machine, but it's still a very useful method to debug things quickly. If you want to print really quickly an object, you can just use stringify, and then boom, you just display it. All right, now there is also the basically the pair of this function that if you have it in a string allows you to take it back in as an object. So perhaps let's since we have this already in a string, let's make car clone. Let's make a clone of our car by just replicate it from the serialized state. The way to do that, we just say json.parse. And then here we'll have to pass a text or a string, right? So at this moment, car clone should be an object which is different than this object, but should have the same kind of properties as the one above, right? So perhaps let me, so the same line that I put above, let me write it here. But instead of car, we're gonna put car clone, car model plus. I can wrap a line in a single line on multiple lines. Here we have punctuation signs, so that is just fine. So this line, though it's exactly like the one above, like this one commented, we are working on the car clone variable. So let's see it. And it's working! This is the serialized state, and this is basically the new this information is displayed from the new object that we created from the serialized state. All right, so let's create another example, another object here, really quickly, just to practice a little bit more. What about, let's say we are building an application where we want to store various users, right? Well, you can store a user very easily in an object, for instance, or person or user of a system, right? So we can make use of this concept of objects, and basically we can store persons inside our application, and a person or a user can have various properties. Perhaps it has a first name, last name, age, email, password, something like that access the system. And I can define a property named fname from first name, and you know, can be I'll just pick here a generic name, so it can be applicable to anybody. Last name, though, and then perhaps it has an email, this user. What email can I don't know. Something invented, this thing doesn't exist. And then has a password, right? Probably it's not a good thing to store the password in the code, but just for example, this is how we will define this user basically. And more interestingly, I mentioned to you that we can have, since these are variable, let's say user1 and user2, and perhaps this is Jane Doe. We can have an array of this kind of object, so we can pass them to functions. So let's have an array, users. This array can be just like that. And now, since we have them in the array, let's see how we can basically iterate to the array, just to recap some of the previous concept, and display just the first name of these users, right? So the way we're gonna do, we'll just say for let user of users. We remember this syntax for of that we encounter it with array. We can iterate to the array. We can take any variable. I said here user. I don't think I used it before. Yes, it's not used. This is user1, user2. I'm just picking one user, and then I can say println user dot fname. And because these are objects, I know that they have an fname property, so I can use it basically. So if I run it, see, I can see the two users here. And feel free to just pick any, create a database. You know, if you don't just put any random names. See, I changed them and they just run fine. So yeah, so this is basically how you define objects, how you use them in the code, and as you can see here, we can place them in arrays. Actually, having an array of objects is a pretty interesting concept, and we're gonna explore it a little bit more today. Let me. This one is just a scratch code. I hope you're taking notes, because I'm gonna just remove it. And now let's create a little bit, perhaps something more interesting. I'm trying to locate here an example. Yeah, perhaps this one. Let me see if this is, yes, this is the right one. I like these little cars. So in this example, we defined, if you remember, 3 cars. Obviously, you can see them on the screen. But we define several sets of variables for these cars, right? We define the speed, we define the car, the positions for this car. So let's refactor a little bit this example, and instead of using this kind of different set of variables, and then when we took the decision here, we had to basically, for each of these variables, we had to compare it with a certain number in order to reset it. Instead of doing this, let's try to refactor it with objects and see that also the code will be a little bit simplified. All right, so let me save a copy here. So this is cars with objects, and perhaps I should define 3 objects really quickly here. Car1, which is an object that has what properties can it have? Has an x, that is the position on horizontal. It starts at -200 and has a speed. And speed, we can also assign it a random number from the beginning, just like that inside. So instead of putting here a value, we just put an expression. All right. So car has an X and a speed. And let's add that property here. Has, say, a color, right? So car1 is red. That's good. So let's define two more objects, car2 and car3. This red, green, and blue, I think were our cars initially. Yes, and we have car1, car2, car3. All right, so we have the three cars. We don't have to keep their speeds and positions separately here. And perhaps we should even add them in an array. Yeah, why not? Cars equal car1, car2, car3. And this is how we add them in an array, right? Very good. Let me complicate the things a little bit just for fun. Because when we worked with users before, this is how we added them. So it should work just fine if we run it, of course, after we fix this program. But I can show you that we can add, we don't have to define this variable individually, car1, car2, car3. If we add them in an array, I can just take, for instance, the first element here, and instead of car1, this is the guy. Let me see if I close it correctly. All right. Instead of car2, I can put it on the other line just to see it a little bit better. This is the element, and instead of car3, this is the element. It looks a little bit more cryptic. So if you are not familiar, or this looks too complicated for you, just define the three variables independently and then place them in an array. Probably it will be a little bit easier. But I want to show that we can also do this kind of thing. So we don't have the variables defined independently, but instead inside this cars array, and we know that it's an array because it starts with square bracket and ends with square bracket, we have three objects here. All right, so we have no choice right now. We cannot access the car by their names. So let's see how we can access them. Let's look here what was happening inside the loop. Here we are trying to display the cars, the three cars, using this function that we inherited from one of our very, very early programs. So we're gonna refactor the code basically to display the cars, and then here we are basically updating the cars, right? So perhaps we should do this. We go inside the loop, and let's loop through all the cars. For let car off, and this can be a constant. No, let's make it a variable, doesn't matter, or constant, better. So we're gonna loop through the cars array here, cars, and for each of the car we want to basically display it and then update it, right? So let's maybe name this display car and update car, and we'll make the function, we'll have to create these functions, and we'll have to accept them a parameter. We'll have to make them accepting a parameter. So they'll accept the parameter car, right? All right, let's build these functions, and then we'll have to clean up this code. So here, this code have to go away, but not before making the functions, because we may lose the logic. Function display car takes a car as an argument. We said once we have an object, we can pass it around, we can put it in arrays, we can pass it to other functions. So it's just fun. The entire car object, we are just passing it like a simple variable. And let's create another function here. Function update car will also take a car like an argument, right? And now let's see what logic we had for displaying. Pretty simple logic. All right, I removed the other two lines because we need just one line. The function was car. The function was car. The car, which is this one, is basically displaying a car. Notice this one takes different arguments. So we'll have to basically extract them from our object. So we have to provide car.x. 50, I think, is the y position, which we hard coded. That's a problem. So let's see. Let's place also y position here inside, because right now we cannot hard code them. And this one was 250. I don't know. We'll just put like some numbers, and if we can adjust them afterwards. 450. So 200 more, 200 more. Let's try with these numbers. All right. So we display not at 50, but at car.y. And then instead of red, we display car.color. Just like that. You know, this function, because it has only one line of code, we could have not used it. We could have just invoked this one directly in the above, but you know, we can just leave it now here. And this is something that we have to do for update. Let's move the other code. And this is what we have to do for update. But notice, before we had to do it for each one of the 3 cars, we'll have to simplify the code here. We can just do it for a generic car, because we are invoking in a loop this update function, the same as the other one. So it will be invoked automatically for the 3 cars. So here we have to increase the x property by the car.speed. And then if car.x is greater than 800, so basically goes outside of the screen, we just reset it, bring it back a little bit to the left. And also we are changing the speed to a different random number. All right, so this is the update. Let's review the code again. We have an array of cars. These cars, they have these properties, x and y, and different speeds and colors. And then inside the loop, and as a reminder, and for people that are new to the stream, loop, it's a special function. We don't have to call it, but gets called automatically by us, by the browser, to say like that. It gets called 60 times per second. So 60 times per second, we are repainting the screen. We are clearing it and then repainting the screen. And the way we do repaint, we basically display all the cars, and then we update the state of the cars a little bit. And then when this loop repeats again, we'll basically make the car move a little bit to the right. Inside the display, it's a pretty simple display, calling the function that we already know that is working. And update is just working like we said. We are increasing the x coordinate by the car speed, and they having different speeds will make the car move differently on the screen. And here we are checking for end of screen. Let's run it. Let's save it first and run it. Okay, car is not a function. All right, where is not a function? Oh, yep, car.x, and yes, here is not a function, right? We are trying to invoke the function car here. Listen, and we are using the same variable. So let's name this one, rename this one draw car. Yeah, so display car is calling draw car. And if we run it, program works the same as before, but it's a little bit refactored with cars. And actually it's pretty smart, works smarter to say like that. We can basically, if we want to add more cars on the screen, we don't have to go in this code here. We'll just go and basically add a new car. Like here, if we add a new car in our array, let's try it, 550. And we're gonna choose a color here, magenta. If we'll add it here, notice we have a new car, but it's running down there in at the bottom of the screen. So you know what? Perhaps instead of assigning y values here, like 50 to 50 and so on, perhaps the program should look at how many cars are in the array, and then recalculate the y value. And then we can just add cars, and then as many cars as we add, it will calculate the y value, and we recalculate also the zoom factor. So basically we can fit as many cars as we want on the screen. Right, but that's beyond the exercise with objects. You can do as an exercise at home if you want. I'm gonna put the program in the chat here. Car with objects. click on the link, you'll open it on your side and modify it. Again, one thing that you can do is just eliminate the y variable here. We don't need it, and basically just calculate it inside inside the display. Basically, figure out what will be the, or here instead of the loop, inside of the loop, figure out what will be the y and pass it here as a extra parameter to the display. All right. I hope you like objects, right? They are pretty cool. They allow us to group all these variables instead of having them loose in the code there. We can group them in a bigger variable, in an object. That's a simple name for an object. Let's do another exercise. And I'm also thinking at one that we built before. Let me see if I can locate it. Give me 1 second. I'll put you some music. This is it. It was fast. Do you remember this bouncing ball that we said that we tried to recreate that effect of bouncing DVD logo? Well, this is the code. How can we make more bouncing balls, right? So let's, you know what? Let's recreate the program from scratch, just to be as a practice. We're not gonna reuse that one. So, how can we create multiple bouncing balls on the screen that they just go in all directions, bouncing on the edges, and perhaps they can have even different colors? Why not? So let's have an array of balls, basically, that we want to bounce them on the screen. And perhaps we can create a function. Yeah, perhaps we can create a function create balls, actually, that will create all the balls that we want, and we're gonna create them as objects with certain parameters, and we're gonna place them inside this array, right? So, and maybe we can make this function return the array. So we can have it like that, and here maybe we should pass them how many balls we want to create, n, right? Okay, it looks good. So this function, we intend to return an array, and basically once we invoke it here on the first line, this will return an array of various balls that basically will have this parameter. So let's create a for loop. Let's have this like an inner array first of all. Let AR, we'll just use a temporary variable here, and then we're gonna create a loop from 0 less than n I++, because we want n balls, and then we can say let ball equal, and we'll have it as an object. All right, and then AR push, we're gonna push the ball, and at the end here we are returning the array, this array. All right, let's see what properties we need for a ball. And if we remember that example that we just saw with one ball, we for surely need an X. And let's say it maybe starts at randomly on horizontal, each ball, and Y, random on vertical. It needs a DX, a direction, or a delta X that will basically specify how many pixels we move the ball on horizontal, and a dy how many we're gonna move on vertical. And we're gonna also use it as a random. Now we're gonna pick a random value between -1 and 1, and we also have this function at our disposal here in the library. But if we don't want to rely on the library, we can recreate it pretty simple. But this function, it takes an array and picks a random value between from this array. So dx will start like either -1 or 1, and let's redo the same for dy. All right. So now we are imagining a ball is created somewhere randomly on the screen and will go in a random direction that we don't know exactly where it's going, and we don't care. So we should have this array. Let's make sure that we have it. We're gonna put a print ln and print basically just the length of it. See if it's getting indeed populated. Bouncing balls. I'm gonna save it, run it. We have 10. Let me share this one with you on the chat. If you are opening from the beginning, you'll see my code here. If I'll save it from time to time, you just reload it on your side. Bouncing balls. All right, it is there. All right, so let's make now a function that will display these various balls. So we're gonna create a function, display. Actually, you know what? Let's not display all of them. Let's make the function to display just one of it, just one. Let's say an object of type ball. And why I'm saying this? Because I intend to create to invoke it in the loop and leave there the for loop that goes through all the balls and calls into this one. You know, we can leave it. You know what? Doesn't matter. We can display all of them here if we want to. But we can also display just one of them. And how can we display it? Well, we can just use a circle. Just use a circle for now at ball.x, ball.y. Well, we don't have a size for the ball. Well, we can put it here. Size. And let's say it's a constant for now, 10. And even a color. And what we can do, we can use the function color that is similar to fill, but this one will return a color. But we have to make the color random. Let's make a column random as well. Random to 255, random to 55, random to 55. Right, so this one, this function should return a color that has the RGB components totally random. And basically the function, the color function is coming from the p5.js library that it's used by the, let's see it here, that is used by the codegrappy.com environment. Is this guy here, that the one that you see, but we use it, yes, with 3 variables like that. So this is another source of information if you want to find out some of these APIs that we are using here. In the future, I'm going to show you how to transition smoothly from codegrappy to p5.js. But for now, you don't have to consult the p5.js reference unless you are just a little bit more advanced user. So we're going to display a function of this here, and ball, let's name size is actually r from radius. And how we're going to fill the circle, we're going to use the fill color with the ball.color. Right. All right. So let's create a loop. If we let's not create loop, let's just loop ourselves through all the balls first and display them. So what can do, we can create here a loop, a for loop for let ball of balls here, and then we're gonna invoke display for all this one, for this one. All right. And if I run it again, yes, they should come in different positions on the screen. All right, because look, we initialize them here with random values, and this one they get created, and this array is populated with all these random things. But we don't want just to display them statically, because we just obtain one frame and we want them to move. So instead of calling them in here, we're gonna place this code inside the loop function. So let's define the loop function. Loop, and this code will go inside. We'll just indent it a little bit because we want to see it more clearly. And before we display it, let's clear the frame and display it. If we run it, it will still look like a static frame because we don't change the coordinates of these objects. But let's create another function here. After we display one of these objects, we'll go and update the various parameters, various properties of the objects, right? Let's create a function update that is similar to display. And since we are calling it inside this for, we'll also pass just one ball as an argument. And this guy, what we'll have to do, we'll have to look at x property and actually increment it with the ball dx, and do the same with the y property and increment it with the ball dy. And next we have to put those conditions if they bounce to bounce from the edge of the screen. But let me save it and run it and see how they go away. All right. All the balls are going in all the directions, and soon they leave the canvas. Bye bye. All right, it's working, but it's still not good because we don't want to lose them. So we have to check here. And we'll do the same check as before, if x is greater than 800, or if basically it's less than 0, meaning the other direction. In both of these cases, that's why we put an or, we invert the direction, or invert the speed, direction, delta x that we add to the x. This is the meaning of the dx variable. So we invert it by multiply it with -1. Whatever value had before, we change the sign, basically. And we have to do the same with the y property. All right, let's see it. And before seeing, let's take our chances and put here a 100. We want 100 on the screen and run it. All right. Look, it's like this chaotic system of things moving, but the problem is they move at the same speed. Let's make, instead of perhaps instead of dx and dy being a discrete value, either -1 or 1, let's actually make it a random between -5 and 5, just like that. -5 and 5. It picks any speed between -5 and 5. Let's see how it runs. All right, some are faster, some are slower, but all they just go there and bouncing on the edges of the screen. It's good that none of them is 0, because 0 would have been a shame. They wouldn't advance, but all right, they look quite nice. And we can vary also the, well, we can vary also the radius if we want. We can make a various different radius here, and maybe we can put a rule like the bigger balls move slower than the smaller ones. So yeah, we can do also that thing. Yeah, let's well, I can leave this as an exercise. So yeah, I hope you like it. It is really cool. I like it a lot. Let's you know, if you want to make it really interesting, this one, you can go here and place a nice pattern just to have a background for these objects to move on. Perhaps this okay, this green pool kind of fabric, let's put it at the beginning here, even before, it doesn't matter actually. Let's run it again. All right. Let me save it again. And the way we achieve this one, let's look again at the code. Our object is only created here in this function, create balls, this one. This one is basically returning an array of this kind of objects. They are created here. And from this point on, after this first line is executed, in this array we have just this kind of objects. And we can iterate through the array like we discussed. We can use a for with an iteration counter, or we can use the for of kind of syntax that we use here. And we are accessing each and every element of the array, and all these elements will be objects. Therefore, because we know that they are objects, we can access their individual properties with the dot syntax, like .x, .y, and so on a particular object. So this is how we basically, in an essence, you define objects and you you use their properties. Yeah. Let's make one more exercise. Why not? Because practicing is just make things remember. Let me locate. I'm just trying to enhance some of our previous exercises with a little bit more advanced kind of functionality. Let me see this guy. Yeah, I'm gonna the one with the spider that's stick to the mouse. All right. Let me save a copy. Spider with objects. All right, and yeah, so basically, let's remember how we build this one. We had the spider data, or the bitmap of the spider, defined in a bidimensional array, an array of arrays. Each row represents basically each row represents each spider row. It's an 8 by 8 matrix here. 0 means empty square, 1 means filled square. So when you run this one, you obtain the kind of the spider sprite kind of thing. So let's try to have this one in an object. Let's see if we can make it in an object. We can have a spider object that has, first of all, has data. Let's have this property is data, and the data is the entire thing here. Boom, just like that. Data is this bitmap that contains the data of the to draw the spider. Let's say it has a dot size. This loose property here, it's also inside 16, and color. Let's say it's maroon, it's also inside. All right, we can get rid of all of these things. So we have encapsulated here the data for the spider. We have at what size to draw it and also what color to draw it, right? We just pick these properties. We can put more inside. And now what we can do, let's maybe instead, we can leave this function as is and create a new one to wrap it, like we did before with that one with the draw car, and we wrap it in display car. But this time let's just modify this one. So instead of being like this, we're gonna modify to accept not an array, SPR, I think it was an array, but accept actually accept an object of type spider, right? So here, this one is SPR. Sometimes some people kind of, to know the type of a variable, they prefix it. Like if it's an object, they put a small o in front. If it's an a string, a small s in front, and so on. It's not recommended to use this kind of prefix, but it's still very useful in certain situations. So it doesn't hurt anyway. It's just the name of a variable. So let's say this is the variable we are receiving, and inside we can extract from this the data one, right? And we extract it in a separate variable, so we don't have to modify the code below. Otherwise, we would have to say, instead of SPR here, we'd have to say this guy, ospr.data.length, which makes it a little bit messier, I guess, right? So we want to do this one, and then the color, it's also inside. This time we can take it directly. It's basically this one dot color, right? So color, and the dot size is also inside. It's called dot size. So instead of dot size, we say ospr dot size. dot size. And I had the text a little bit small, but I hope you were able to see it. All right, so this is our function to print a sprite at this particular coordinates. Now, as opposed to the cars below, we left the where to print it outside. We didn't put it inside the sprite, so we can basically print it in different position, the same sprite. So let's see it. Dot size is not defined. Where is not defined? Let's see where we have dots. Oh, we had it in multiple places. Oh, we had it also here and here. We have to update the code exactly the same, and our spider is back. I can save it, and basically it's not too much different from the program that we had before. We just encapsulated all these guys in a single object, but why not take the opportunity and make a little bit more spiders, right? Perhaps we should have the same like with the one with the bouncing balls. Let's create an array here, spiders, just like that. And what can we do with multiple spiders? We can bounce them on the screen like balls, or maybe they should fall, right? Because spiders, they fall on a single thread line. So let's make them fall. Let's see. Right. There are multiple ways of doing it. Let me grab my notebook, and I'm gonna attempt to do one of the ways that I'm thinking. Well, this is our canvas. This is our canvas here. And one way of doing it, I'm thinking of two ways. One way, we can create spiders here and they'll start to move down, right? And another spider will be created. Perhaps this one is already and is moving down. And this guy here, let's say this one, it's already here, is moving down. Once goes outside of the screen, we're gonna remove them, right? So all these guys can sit in an array. So once they go outside of the screen, we can remove it. And then randomly, we can insert new spiders, right? So, and if we can control the frequency, we can insert them faster or slower. Basically, we'll be able to achieve the effect, right? So insert them, the spiders on the top randomly, and then once they move down and when they exit the screen, we can remove them. I'm thinking of a little bit different way to do it. Although we can do this one, but I think we created an exercise last time where we did this one. I'm thinking now to create like this. So basically we're gonna build all the spiders ahead of time in a virtual area. This is the canvas, right? But we're gonna build the spiders at various positions here. And we're gonna make them go down. Of course, they'll not be visible since they are off canvas. They are outside of the canvas. The canvas starts here. But you know, the ones that will be in the canvas, they'll be visible, they'll move down. And what we can do, once they reach the bottom, we're gonna recycle the spider in a sense and make them jump at any other random position with a certain area here. Perhaps the canvas is 600 pixel high. Perhaps we should make this hidden area 600 pixels, right? So in certain applications, it's good to recycle these objects to prevent, you know, creation and destroying, which may be a little bit may create memory fragmentations, perhaps not to some tiny spiders, but if we have big structures, that may kind of create memory fragmentations. All right, so what we need to do, we need to create a function to create spiders. We're gonna just build them in that invisible area there, and then yeah, let's do that one first. I will take it baby steps. Let's create a function here, create spiders, and this one will return an array. We'll do it exactly the same as the other one. How many spiders? That's a good question. N spiders. We'll figure out later on. I0, I less than n, I plus plus. So what we'll take this guy from here and we're gonna put it here. Let me use a let variable, let keyword, let spider. Okay, now you know it's a little bit overhead to just have the data inside, because this is more like a template for a spider, but we can see in the future how can we have templates for objects using classes. But for now, we're gonna just replicate the entire thing here. Each spider will have its own data and so on. Dot size, perhaps we should make it smaller spiders. Color. Now let's define an X and Y this time. X will be random to 800 on horizontal, and the Y will be a random between -600 and 0. We want to basically draw them in that invisible area on top of the screen. So these spiders, once we create them, we're gonna say AR push spider, and let's return the array here. And actually let's create here, instead of starting an empty array, we say create spiders. And let's create just 10 spiders in the beginning. We are scared of too many spiders initially. So yeah, this is a good function. I hope it's working. We can test it if we want, like we did in the previous exercise. We'll have to put a println somewhere, debug it. Actually, let's test it. First of all, yeah, it's not working because we broke the logic here. We don't have the spider on top anymore, so if we want to test this one, we'll have to comment out the rest of the code. So let's hope this function works. If not, we'll be in big trouble, but let's hope it's working. All right. Now we need a function to display a spider. A spider, which I think we have it one is print spider. Okay, we can use this one, and let's create one then update spider. Yeah, let's use one update spider. Well, let's create also the display spider just to make them a little bit symmetric. And basically takes a spider as an argument, which is an object spider. Spider. We could have named this one spider instead of or SPR. Huh. Yeah, this is we naming putSprite like something generic, but this one, let's say spider. And the way we're gonna do it is basically invoke this one. It's as simple as that. And takes the argument the actual sprite, and this one also wants to take an argument where to display it, but we embed it inside the object the x and y. So let's extract them here. So it's basically at spider.x and spider.y. We just display it like that. And now we need a function update spider as an argument, and this one we're just gonna make the y coordinate. We'll increase it with we can have a spider speed here, which is or a dy. We can name dy or speed in this case, which is a random between 1 and 3. Yeah, some spiders may move as fast as 3 times as others. So this is spider.speed. Spider.speed. All right, so we update it, and then we check for that condition. If spider.y is bigger than 600, so goes outside of the screen, what we can do, spider.y, is randomly we select a new value in that interval. And why not, we can also make the spider x, we just place it randomly against somewhere else, just not to come on the same direction, just to be a little bit more unpredictable, right? So we do this one, update spider, display spider. All right, so inside the loop, all we have to do is to inside the loop we have to loop through all the spiders. So let's do that. For let spider of spiders, and here we just say display spider. Of course, we'll take this guy as an argument and update spider. Again, takes a guy like this one as an argument. And by the way, we could have created display spiders instead of spider and update spiders, and would have placed the loop inside of this one. The only drawback with that one was that loop would execute twice, but probably the code would have been a little bit more clear here. But anyway, all right. So we have these 10 spiders. As they go outside of the screen, they should jump in that area, so the program should just run like that forever. Let's make it a little bit more realistic, perhaps. When we are displaying the sprite. Why not draw a line from spider x, from the spider position to spider x, and on vertical he's 0 here. Oops, no, we don't have a nice line. What's happening? Stroke spider dot color. We do have color inside the spider. Yes, we do. Let's try this one. All right. They have their own. The only thing is that I don't like the line. Maybe we should center it, and we can do very well that because we know exactly the dot size, spider dot size. So it's basically here. It's let's say let dy, or yeah, a dx, a small variable. How much we should offset the line on horizontal. So it's basically spider dot size times 8. There are 8 cells, actually times 4 because it go till the, yeah, till the middle of the spider. So let's add one of these variables here, like that. A little bit of offset, and the string should be in the middle of the spider. Yes. Boom. The only problem is that they just snaps. The string just snaps like that when they touch the bottom of the screen. Still is a cool effect, I guess. We can make them different colors. You know, we can make them sounds when they touch the bottom. But all this was achieved with basically objects. Let's not forget the purpose of the today lesson. Let's put more spiders, and then I'm gonna share the program with you. Perhaps 100 of them. No, too much. 10 work fine. Yeah, 10 works fine. Let me share it with you. This is not longer spider. This is an army of spiders. Let's name it spiders. And I'm gonna share this one with you. Spiders. All right. So yeah, this is how you basically define objects again. This is how you use them. Let's take one more exercise. Perhaps this time let's type again the definition of an object inside, not to forget it, because in all the previous examples kind of hide or bury down the object. Let me see. Let's make a list of let's make a list of stars. So let me Google here common stars or well-known stars. Most famous stars. All right. Okay. Polaris, Sirius. All right. Betelgeuse, Rigel. Okay. These are well-known stars, but why not just start with our sun? Okay. So let's say sun. It's an object, and let's put here a few properties about the sun. Properties of sun. What can we put? Mass, diameter. Let's put the radius, which is basically this one. Let's put radius. And numbers, I just copied this one, but we cannot put them like that. So this is basically the radius with a certain unit of measuring kilometers here. Let's put also the gravity, which is 27.94 g. And if we want to basically define variables for other planets, of course they'll have different parameters here or properties. So this is gravity. This is specific to our sun. Okay, so this is an object basically, right? Yeah, it's working fine. It's not displaying anything, but when I run it, and since I didn't get an error, it means the code works fine. But I want to show you something else here. What I'm thinking is just to show you that as properties, until now we had simple values such as numbers or strings, but we can have even arrays or arrays of other objects. Let's say our sun or solar system has planets, right? So it doesn't have only one single planet, has multiple planets in the sun. There are multiple planets. So we say planet, it's an array. And now, since it will be a lot tight to type it in here, I'm pressing some enter. And I make some space here. And I'm gonna place some objects inside. Just like that. 2, 3 planets, right? What are the planets in our solar system? Mercury, Venus, Earth, Mars, those ones. Let's just see them here really quickly. Planets in solar system. All right. There are 8 or 9 planets nowadays. Who knows? Type it in the chat. There's a controversy with this one. Well, let's find another one. List of planets in solar system. Okay, list of planets. Mercury, Venus. Let me just copy this one. properties list. All right. And I'm gonna just temporarily paste that information there. So planets are objects here. I'm defining them as objects. So I can have basically a name property for them. For instance, Mercury, right? That's what we intend to do. And then for each of the planets, we can have also other properties. Perhaps we can have what is the gravity, what is the radius, and so on and so forth. So let me just quickly put here these properties. Mars. And do you remember the exercise that we did when we studied the variables with the planet Mars and how many people can live on Mars? I think it was a fun exercise. I hope you like it. Jupiter. Ah, 3 more. Just 3 more. Saturn. I should have typed them. I think would have been faster than just copy paste. But bear with me, I have 1 more. All right. All right. Here it's a comma. I missed a comma. All right. Since these are elements inside an array, I have to place a comma after them, right? Because elements in an array are separated by a comma. And who's the array here? Planets is the array here, right? So yeah, we can have the solar system defined like that. Perhaps we can define other star systems with other stars inside. We can have properties, or perhaps just this one we can now use it. It's just the entire thing is just in a single variable, sun, or we can have it solar system or sun, or I named it sun since it refers to the sun, and these are the planets that gravitate around sun. Now, what can I do with this variable? Well, I can pass it around, I can stringify it and send it over the wire to somebody else, or I can basically use it in a graphical program like we built until now. Perhaps I can draw some circles, draw the orbits, and draw the planets. Pavel, this says there are 9 planets in the solar system. Yeah, let's put Pluto here as well. I like Pluto. It's a nice, cool planet. Right. So we won't do any of that sort right now here, but let's see how to access. Let's maybe print really quickly the planets and also exercise the for a little bit. So how can we print the planet? Because it's an array, we're gonna loop for let planet of, and now of what? It's sun.planets is the array. Sun.planets. Here we have to put the array, but since the array is not in a variable outside, we use the variable sun.planets, right? And now we have access to the planets inside, and we can print ln just the planet.name, and we don't have any other properties right now defined here. We can define other properties. Let's print them. Oh, look, here they are. All right. So mission accomplished. This is a solar solar system. Well, mini solar system. It's not doing many things, but it's a good practice exercise. I'll put it in the chat. Solar system. All right. Should we? So basically here I created this object that has a little bit more properties. So just to show that we can create really complex objects, and sometimes you have to basically, when you are looking in the editor, to collapse them and drill down into properties. Remember, each of these object can have other properties. Perhaps the planet has moons, right? So here Earth can have a property moons, or all of them can have a property moons, right? And this one, of course, will be of type array. And inside this one we can have each moon defined also as an object, so we can imbricate them a lot here, right? So this one is a name, and let's say it's moon. And just like that, so it is running perfectly. So I just placed a new property moons inside this object, and the value it's an array, right? These ones, they don't have it. There is a way to check if the property exists at runtime. Perhaps I should show it to you right now. We plan to discuss about this one more in depth in the future, but let's list also, okay, since we are listing the planet name, let's list also not all the moons, but at least how many moons a planet have, right? So next to it. So how can we do that? I'm gonna show it to you. So we need to access the moons property, which is an array. So it's moons.length. So one way to do it, it's right, we put a space here and then we say moons.length, just like that. And I'll run it. Moons is not defined. Oh, of course, moons is not defined. Planet.moons. Because moons is a property of planet. And length is a property of the array, because moons is an array. Let's run it. All right, cannot read length. What's happening here? These guys here, they don't have any moons object here, any moons array, right? What we can do, we can have a moons in all of these. We can have it like that. Perhaps this is fine. This is an empty array, and I can go quickly through this one, and I can basically check. And let's just add it really quickly. Oh, we should have stopped at 8 planets. Now we have 9. I'm kidding. We could have just put 3 as an example. All right, but bear with me. We have just Pluto. Let's run it right now. And now we see Earth has one moon, and next to the others is 0. But the question still remains: what if a planet doesn't, or one of these objects doesn't have a property, is missing, like this one? Moons is not existing, right? These objects are similar. We expect to have the same, but still this guy doesn't have it. We obtain an error, right? Because what's happening, we are trying to put length on something that is not existing. Well, the way to do that, we can check if this guy is exists or is defined or not defined. There are multiple ways of doing this one, and in the future, again, when we're gonna talk about truthy values and so on, we're gonna see more precisely how to do that. But for now, it's just remember, it's easy to remember that to check if a property is not existing, just check with an if like this. For instance, let's take all right, let's take a variable here. Let's assume a number of moons, let's say 0, and they say like this: if this property exists, and we just check it like that, like we are checking a Boolean variable, it behaves this way. Then number of moons equal, and is the entire thing here, and here we put instead number of moons, just like that. And if we run it, now it's running perfectly. Let's notice the code again. The difference is that we are not accessing the moons.length property unless the planet moons is defined, basically. And look, what we can do, I can also we can also put here really quickly. We can also put here, let me temporarily comment how this code. So we have this whole thing, we have just an object. Let's print here sun dot. Let's access the planets. Dot. Let's access not dot, now this is an array, it's 0, 1, 2. Let's go for Earth, planets of 2, dot moons, dot length. Let's just print this variable is 1. We are printing how many moons are on Earth or Earth has, or you can, if we don't put dot length, if we put like that, we're gonna see should be, oops, moons of 0 dot name now, just like that. We should display, we should see this moon, right? All right, but let's check what's happening with Mercury, which is planet 0. Let's put here planet 0 dot moons. We just print it like that. We don't try to access to index it because it's not an array, we know, but let's print it like that. It says undefined, right? So what it means, these missing properties, because they are not here, their type is undefined, and that type undefined basically is behaving like a false value, and because it's behaving like a false value, we say if planet moons, if exists, basically if it's defined, if it's not undefined, right? So if it's undefined, behaves like false. So for all those that are false or undefined, this line won't be executed. And now number of moons will remain 0. So we just reverted the program back. Solar system, save it. It's in the chat there as well. All right. Let's see. One more exercise. We still have plenty of time for today. We don't need this one. Let's see what we can pick here again to enhance a little bit. Let me see. Let me put some music till I'm thinking. All right, we'll pick this one, but we'll not keep it animated just because the animation we said that's a little bit more advanced, and maybe some of you, I don't want to get basically lost into unnecessary details. So I'm just copying the code here, and let me clean it up and remove, you know, as a matter of fact, I'm gonna just extract, I'm interested just in the basic code here. All right, and instead of grow, yeah, I don't need any grow. We don't animate it. I think these are the original values, and then 124 until here. I hope I'm not messing up too much. Let me see if I can revert back that drawing that we started with originally. All right, let's see. Yes, and name this flower with objects. All right, so this is a simple program that draws a flower with code. Perhaps we should make use of functions right now. Draw flower, and we can encapsulate this loose code inside this function, and we can just call it just like that. Should do basically the same thing, right? Now objects, this kind of objects, and the reason I brought this example here is to show that these kind of objects are also useful to specify extra argument to some functions. It's a common pattern encountered. So for instance, what if we want to extend this draw flower and specify, okay, I want now to draw the flower using color red. Perhaps, you know, we can make here an argument color, and I want the stem to be green. Okay, color petals, and I want the color of the middle part, middle part to be here, and then I want the color of the stem here, and then I want the size or something like that. We can parameterize this function, and then when we're gonna invoke it, we're gonna just pass all these colors here, just like that, right? Sometimes the kind of parameters that we intend to send to our functions may become to a big number, and therefore it's much easier to pass a small object with all these values, such as an option. So perhaps the flower should take an options parameter. And then when we are invoking, we'll not put the arguments like that. We're gonna build a small objects and then invoke it. or we can build the object directly in here in line. So inside the function here, notice what I'm doing. I'm opening and closing curly brackets for an object, and I can put here the property color, and let's name it red. Just like that. Looks funky, but I'm assuring you this is a small object. I just passing this object as an argument, right? And the argument is options. So where should we use this one? Perhaps here, instead of drawing the flower with red, we draw with options dot color. Well, let me name this one petals. Let me petals. All right. So let's run it. We still have a red flower, but if we're gonna put here some other color, we have a different color, a different kind of flower. And then we can have here maybe, you know, maybe we're gonna build the yellow part with instead of yellow. Yes, we can also have here option dot I don't know how do you call this one in a flower. If you know, put it in the chat. I'll just call it middle part. So, and then we have to pass it here. Middle part is yellow, and the program. Oops, option is not defined. Yeah, options. And it's yellow, but if I'll change it here in orange, of course we have a different color here. So yes, objects can also be used in this way to pass to create functions that take fewer arguments. Draw flower can perhaps take an x and y where to draw the flower, so we can still have, okay, I want to draw it at x and y coordinates, but then I can passing an options here, right? And maybe I wanted to draw the flower these coordinates, and I can pass an options. And also one more thing, we saw that options, exactly like properties, we can skip it. So perhaps somebody can skip this one and just invoke it without passing an option. Of course, we'll have to do an extra verification inside if this option arrive. If options, we can use the same syntax, then we're gonna use the colors inside. Otherwise, you can use some defaults. But perhaps this is for another time. I'm kind of linking into other lessons, and is beyond the scope of the just pure working with objects for now. All right, so we can see that we can use it also to pass options to some functions. Let's make use of this one. Actually, no, because we have to parameterize, takes a lot of time. I'm not sure exactly where the stem is and so on, but yeah, right now these are not used, but feel free to extend it and use it, and you know, I'm gonna share this code with you if you want to practice on the code. So this is flower with options. Another great use of objects if we want to return multiple values from a function, right? So we worked many times with functions until now, but from all the functions we return just one value. So we're gonna build a more complex one in a second, but let's take a simple example here. Yeah, let's create a function add that takes two numbers as arguments, and we'll return the sum of them. Let's create a function multiply that takes also those numbers and return the product of those. Pretty boring functions. We should not do this one, because who's doing this one? But well, for the purpose of the exercise, let's just look at these functions. Now, how can we use them? Well, very simple. We use them like this. We pass two numbers, we take the result in a variable, and we are happy. And then the product, we'll use the second function, and you know, we take the result in another variable, and then we can print the variables, and you know, we can have fun with these calculations. Let's put here product, and this is this variable, right? And should work 5 and 6. Yep, 5 and 6 works fine. But notice add and the mult function from multiplication, they just return a single kind of value. They return either here the addition or multiplication. What if we don't have these functions, but instead, let's say we have a function compute that takes two numbers, a and b, like add and multiplication, and this function is supposed to return both the sum and the product, right? Both sum and product. How can we return both sum and the product in a single function? So inside, of course, we can use them to variables, which is a plus b, and the product is a times b. But the question is, how can we return both? To return one, obviously we can return like that, one of them, right? And we are good to go. But we need both. Two common structures if you want to return multiple values from a function are either to use arrays. So what we can do, we can return them like in an array. And notice I created an inline array returning both values. Now the question here, we'll have to use them differently. So we'll have let result, let's say we invoke compute with numbers 2 and 3, and then our sum, it's actually result of 0. Remember, it's an array, and product, it's results of 1. Since it's an array, we have to specify the various elements by index, which is fine. It's returning 5 and 6. The problem appears if we want to have more and more elements, we start to forget on what position these elements are. Also, it's not possible. Let's say we want to return also the average, right? Well, we can put it at the end and it's fine. But let's say we want to return first sum, then average, and then product. If we're gonna, we can take in a different variable here, average, which should be basically sum divided by 2, let's say. And we want the average to returning on the second position here. The problem with this one is that we'll break the rest of the code that already used the compute, because look, on the second position, this piece of code expects to have the product. If we change the order of elements in the array, we have to go through all the other code and see, okay, is sum still on position 0? Yes, it is. Is product still on position 1? No, we move it to 2. And so on and so forth. So if we are not doing this one, we're gonna break the program. That's the problem with arrays and when we present the numbers basically based on index. However, we have a new tool and the tool are called objects. What if we are returning an object with these guys instead of simple variables? Let's do that one. So what we can do, we can return an object, and here I'm gonna return is one of the very few cases that we have to pay attention. Don't place the curly bracket on the next line like we are doing with functions. We said we are doing these functions because it's easier for beginners, but with return, if we do like that, return will just finish here the function and this one will be ignored. So just make sure you have this curly bracket immediately after return. Okay, so with this being said, what we can do, we can return the 3 variables like that. And notice something. I also want to show you a short way notation for defining properties. Well, one way is to say, I want to return inside this object, I want to have the value, the property named sum. What will be the value of sum? Because until now we saw that to specify the value, we have to put colon and then put a value, which we can. That will be sum as well. And this one will be prod as well. And this one will be average as well. So this syntax looks a little bit redundant, and in the newer edition of JavaScript, we'll talk about JavaScript editions just for now. Just remember, in the recent years, they have a new syntax. So basically, if you are missing the second part here, just like that, JavaScript will return here, or basically will construct an object, not necessarily return, but construct an object that has the property name sum, and as a value will have it the value name sum, or something that can be evaluated to that thing, right? So we are returning this object. So now let's see how much cleaner the usage is. So instead of saying result of 0, it's result.sum here, and this one is result.product. And even if we add average later on and we can add it in a different position, it doesn't matter at this point because we are accessing them by name basically. So we can put here average, and doesn't matter. When we are running it, we should just see, oops, we don't see product. Prod, oh, because I put product here, it's prod. The property is prod, product is undefined, it's like one of the other cases that we saw before. All right, so see how easy we can use this one to basically return multiple value from a function, multiple values from function, let's make a more actually, let's pick up, I remember we created pretty recently that function that calculated, let's calculate something more realistic, not sum and product. Especially considering that we have that, how is it called? Yes, quadratic equation. This is what I'm looking for. Right. All right, this is the perfect function. If you remember, we built this one in 2 lessons. Actually, let me locate the first version, quadratic. So we have 2 versions of it. In the first version, we built it like that. No function. We built it before we learned about functions and when we learned about ifs and conditionals, right? So, and what this code is doing actually is finding the roots of the quadratic equation or second degree equation. And we also took certain cases. If a is 0, or these are being the coefficients of ax squared plus bx plus c equals 0, we took all these conditions and we've calculated the discriminant and so on. It's still not completed here. We have to check some more conditions. Then when we learned about functions, we went and let me locate back that again. Yes, this one. And we encapsulated this one in a function and we invoke it even for 2 being in a function, we invoke it for 2 sets of values, right? For one for this one, which is represents one equation, this one for the other one. So if we run it, okay, has 2 complex roots. This is the answer for the second equation. But I'm still not happy with this function. This function has the printing inside the function. And this is not good. Why make this function to do the printing itself? This function, since it's a mathematical function, should just return the result and let us from outside do the printing. Perhaps we want to do the printing with println, maybe we want to do the printing in a graphical mode, do some really fancy big numbers appearing on the screen. And if we are not doing the printing from inside, we have that option, right? But how can we return all the results? Because basically, if a is 0, we have to return something that says, okay, this is a first degree equation and this is the x value. Otherwise, if you know the result, those coefficients are just right, we have to return this on this branch and saying, okay, it has 2 real roots and these are the roots, or has 1 root and this is, or has 2 complex roots, and we didn't even finish here the implementation, right? So what we can do, we can make the equation not print but return an object, right? So let's see how we can return an object here. So this is a first degree equation. Here we said also to check if b equals 0, because if b equals 0, it's basically, yeah, let's open again the quadratic equation, Wikipedia, just the one that we used last time, just to have it clear here in front of us. All right, so we are checking here for edge cases. Okay, let's move this one. It's just above my head. Ax squared plus bx plus c equals 0. So we are checking if a equals 0, which basically the equation remains an first degree equation. Bx plus c equals 0. We can check also if b is 0. If b is 0, it will, the equation will remain here c equals 0. And then if c is 0 itself, is like 0 equals 0, which is an infinity of solutions basically. But if c is not different than 0, is like 3 equals 0, its equation is not deterministic. So that's a different case as well. So perhaps we can basically extend our program to take in consideration all these cases as well here, because here we left the program a little bit not completed. We say, okay, let x equal, we're on the branch when a is 0, and basically at this point we are trying to find the x value being minus c over b, right? And but if b is 0, this one is also, as you can see, we are dividing by 0, which is not good. So, well, we can also do this one here. If b equals 0, else, so if b is not 0, I guess we can move this code inside the else branch. We are in good shape now to calculate x. But if b equals 0, we can also check if c equals 0 if we want to be very precise there, or you know, it's or we can just say, okay, it's either infinite solution or non-deterministic, something like that. Okay, so let's see. First of all, what we can do, we can have the response here, response or answer, like that, and we'll return it at appropriate times. And let's say we have a type inside, right? A type that will basically be various values. We'll see exactly 0, 1, 2 what will be. Type 0. Let's say 0 is the most common case here, and the other cases are just variations. So type 0, then we'll have an x1 as an x1. Oh, let's have just a type, an x1. Let's be a 0. We'll initialize them with some bogus values, although should not matter, but can leave them uninitialized, I guess. Yeah, something like that. And if they're complex, we can handle that one other time. So if b equals 0 here, we don't calculate any of this one. We can just say response dot type equal 1. Let's say this is type 1, and we are returning response. That's it. Here we are calculating this one, so we can say response dot type equal 2. We are type 2 of response, and we are returning x. We are saying also response dot x1 being x, because we have just x1 and x2 defined there, and now we are returning response. So we are not printing anything, we are just removing all the prints inside. We are on this branch here, which is our happy case here. What we can say, response dot type equal, we set this one to be type 0 because we like it, it's the most common case for the quadratic equation. And then we can say response.x1 equal x1, response.x2 equal x2, and we are just returning. Notice something here. Since we are using return inside here, this kind of else ifs, they don't have the same, well, it doesn't hurt, but we don't need this logic. Return is just returning from function at that point. So anyway, so this one has only one root, so this one is response.type equal, and what will be the type? We said 1, 2, we use the 1, 2 values here, 1, 2, okay, this is type 3. This is type 3, and then response.x1 equal, all right, is this guy here. Return response And this one has basically, this one is type 4, and we don't calculate them, we don't have to put it there. Return response. And if I'm not mistaken, if all these ifs and else's, I think they are correct, placed correct, we don't have to return response after each branch and break it there. We can just have only one return at the end. Here we are just setting what we want to do. Let me remove the return. Yep, I think if else is they close correctly, they should, because they're in the program with the printing. They should not go on different branches. And now at the end here, actually we are returning response. Okay, let's review what we did here. Let me close this guy. And basically we modified the equation, the function equation. We can name it solve equation. That instead of printing directly, it just sets some values in a response object. For instance, on this branch says this guy here. On this branch sets these things here. And these are not visible, right? And then we are returning the response. Because we are doing that, if we run it, nothing will see on the screen. We have to now interpret the response, right? So this one, maybe you should name it solve equation. So if we just run it like that, nothing will happen. We have to interpret the result. So we can have another function now, function print results. And now this one will take an object as an argument, right? The idea is that this one, let's say, returns an object. The second invocation returns another object, and we can have print results of A1 and then print results of O2. And this is the good elimination of that print from inside, allows us to basically print the results however we want. So we can just redo the printing, recreate a different function to print them in a more, nicer way with colors and so on and so forth, without affecting the logic here. So let's see first of all if we can print them correctly. We need to look at the type property, and there is an easy way to look at that one, but for now we're gonna just look it with what we know. So we're gonna check if o.type, and we'll start, we'll start with 0, and we say like that, else if o.type equal 1, and I think we have 4 types. 1, 2, 3, 4. I think we have 1, 2, 5 types here. I don't recall. Anyway, let's see. Type 1 here, first degree equation. Oh, I left a print. Let me remove this one. Yeah, we don't. So that was for type 1 here. First degree equation, and what we are returning in case of 1. No, type 1, it's first degree equation. We can print that one, but we can, type 1 means either infinite or non-deterministic. So we can put another print line here. Infinite, or we can just put on short C equals 0. And you figure out what this means, either infinite or non-deterministic. So we are in that branch. Then for type 2, we have, it's still equation of first degree with one solution. So we can, this one, well, maybe we should just move this guy from here. We are on this branch, first degree equation, and then we can print, which is x equal, and inside, we put the x inside the x1 property, because this object doesn't have an x property. So for the type equal 2, we put it inside x1. But when we are displaying it, we can say x equal, and it's x1. Okay, type 3. Type 3 is basically one, yes, it's one root. So it's basically second quadratic equation with one root, and this one is again in x1, or in this case let's write x1 equal x2 because it's quadratic equal that value. That's type 3, and type 4 is complex. This is complex, right? So this is, and we didn't calculate them, so we'll just print them here like that. Complex roots. And we didn't calculate them again. So here we need to calculate. All right, so it's still not, oh, and we have type 0 here, which is basically quadratic equation with 2 roots, and we're gonna display them nicely on the screen. x1, x2. All right, so let's see if our program runs. I'm not sure if I overwrite it or I saved the copy. Quadratic equation with object. Hopefully I didn't overwrite the whole copy. I'll run it and just writes fine from the very first try. Now, we cannot still be very sure that it runs perfectly on all the branches and switches, branches here, so you have to check with multiple values, kind of create a test case for this kind of code. But anyway, the main point here was that we can use an object to return multiple answers from within a function. So rather than returning, you know, just a number or so, we return multiple ones. So we have a solved equation that returns a response object with various properties, and then whoever is the consumer of that object, in our case it's a print function, the consumer will basically inspect the properties inside and take a decision. In this case we are inspecting the type and making decisions here, and then we are inspecting x1, x2, and so on and so forth. All right, so I think that is all for today. We just say that we're going to take a small scope, and we saw that in objects we can basically, if we do a quick recap, inside the objects we can have these other properties that can have numbers, strings, arrays, even arrays of objects, even other objects. We didn't cover that one, but it's the same. What we didn't show is that inside these objects we can also have functions. Functions inside objects. That's where things gets really exciting, but that's an advanced concept that maybe we're gonna discuss it in the future. All right, so for now I think that right now our toolbox of JavaScript knowledge and commands, it's a little bit bigger. We can create much nicer programs in the future. And with this, I want to say again, like always, thank you for watching. Keep practicing, happy coding, and see you next time.